Hey there! So, in this lesson, we're going to talk about surface area. Now, what is surface area? Well, it's the measure of the total area that a surface of an object occupies, the sum of the areas of its face. Now, I'm not going to lie to you. Surface area, it is a bit tedious because you have to sort of like imagine the shape of an object except flat. So there's quite a few calculations, but well, once you follow along, and then you'll start to get it. So here are some formulas for surface area, volume, and area. You don't really need these formulas because I assume you already remember the most basic ones. You also probably have to know the what the circumference is, but well, when we get there, we'll talk about it more. And again, I always think that doing problems is the best way to learn a lesson. So let's read the first one. Example one, a cylindrical, okay, it's a package, a cylinder package. A tennis ball has a diameter of 67 millimeters. A cylindrical container holds three stacks of tennis balls. Determine the amount of material required for the container to the nearest squared centimeter. So it tells you here that it has to be in centimeters. Now, an easy thing to do, like you can do the calculations and then do the conversion at the end, but I find that a lot of times it saves you a lot of headache doing the conversion ahead of time, like first, and then do the conversion first before you're doing anything else. But I'll show you an example either way, doing the conversion first and then doing the conversion last. So in this one, we'll do the conversion. Well, let's do the conversion last for this one here. So we're not going to convert milliliters into centimeters, not just yet. We'll do that near the end, and I'll show you how that's done, just in case you ever come across a problem like that. So first step is to find the radius. Well, let's take a look here. Let me just grab my pen tool. Well, I can tell right away that here, like from the ball, from here to here, that is the diameter, which is given to us. So half of it is basically the radius. So to find the radius, we just have to do r, and it's the diameter, which we know is from there to here, divided by 2. So we have 67 divided by 2. It's 67 milliliters, by the way, divided by 2. And that should give us 33.5. And this is in milliliters here. Okay, good. So we did that part. So we found the radius, and I'm gonna write it over here so it's a little bit easier for you guys to see. Just so you guys know, sometimes it's not gonna give you a diagram for problems. So it's always a good idea to always draw the diagram in yourself if the diagram's not given, and to mark on the diagram. So that's what I'm doing. And it's for a lot of subjects, especially physics and math, a diagram tells 1,000 words. Okay, so let's find the area of the two lids. So we have a lid here. This is a lid, and that's a lid. So there's two lids here. And if you find the area of one lid, then you just have to multiply it by 2 to get two lids. So, and they give you the formula right over here. That's the formula for two lids. Well, this is the formula for one lid, and they just multiply it by 2. So let's do that down over here. Okay, so again, we're going to use A for area, and we're just going to subscript it for a lid. So I'm going to say here, lids. I'm going to say lids because I want the area of both lids. So I'm going to write down 2 because there's two lids here, times the area of one lid, which is pi r squared. And as you may remember, pi is always 3.14. And that's a constant. This will never change. For all your math problems, it will always be the same. Pi will always be 3.14. So let's write in our numbers. So we have 3.14. And then radius is 33.5 squared. We'll drop our numbers in, and we should get 7,051 milliliters squared. Again, it's milliliters squared because it's area. Okay, so let's do the next one right beside right here. Find the surface area of the body. Now, whenever I see this, well, the formula is given to you up here. That's the formula. But an easy way for me to understand this, because you remember the the circumference, find that the length, define the length around this is basically 2 pi r. So if you travel around, it will always equal 2 pi r, right? And if you put in a flat sheet, if you think about it, if you flatten the cylinder out, it'll look like a flat sheet right here, right? So essentially this here is 2 pi r from here to here, right? And all you have to do is multiply it by the height, and that will give you the body of the cylinder. And if you look up here, this is exactly the formula you have here. Here's 2 pi r times h, which if you look down over here, is length times width. So the width here is 2 pi r, and here's h. So it's the same formula as you see above. So I'm going to write the formula down. I'm going to say body, subscript for body. So the area for the body equals 2 pi r, that's this first part here, multiplied by h. Okay, let's drop our numbers in. Pi is 3.14. Radius, oh, that's a big number. 7051 multiplied by, so that's 2 pi, and then the the height here in this case is this number here. So 201 milliliters. Okay, 201. And we drop those numbers in and we get 42308 milliliters squared. Again, because area is always squared. And so now we have the the area of the lids, 2 lids, and the area of the cylinder body. Now we just have to combine everything together. So I can say total area, or I can just say, well, because we use the word sum, I'm just going to use area sum, which will equal the area of the lids plus the area of the body. Let's drop our numbers in. So that will be, the lids will be 7051 milliliters squared plus 42308 milliliters squared. You get those two numbers together and you have 49493 milliliters squared. Okay, so we have this number here, and now here's an interesting part. This is an interesting technique. I'm going to convert this milliliter squared into centimeter squared. Like normally we do the conversions in the beginning, but in this case we're going to do the conversions near the end, because I want to show you different ways of doing a conversion. Because sometimes you have a number and you don't want to go back to the beginning and do another calculation again, just in case you make a mistake. So there's an easy way. So learning how to do this conversion could save you a lot of time in the future. So what I'm going to do is, well, but we need this is the area of the sum, right? Again, our conversion is done the same way, always done the same way. And, well, actually, no, it might be better to actually show you here, show you the numbers, because it's easier looking at numbers than letters. So the number is 49359. I'm going to write the unit here, milliliters squared. Now, what's the conversion between milliliters and centimeters? Well, I can tell you that 1 centimeter is equivalent to 10 milliliters. Okay, so conversions are all done the same way. I'm going to say 10 milliliters is equivalent to 1 centimeter. Again, I do it like this because every number is really over 1. And, oh, wait, actually, that's backwards. Okay, here we go. Yeah, so that's back. Actually, I do it here like this. 1 centimeter, so that's on top, and then this goes on bottom. Again, the reason why I do that is because this milliliter is on top here, and this milliliter is on bottom, so they cancel out. But you will notice that this is milliliters squared, and this is just milliliters. So what you do is you put a bracket like that, and you square everything here. So what happens is this becomes centimeter squared, and this becomes milliliter squared, and now this milliliter here will cancel out with this milliliter here. So, well, maybe I should expand it so you can see. So essentially, it becomes 49359. This is milliliters squared. And now you have here 1 centimeter squared because this centimeter here applies to both these, so that to that. And over here we have 100 because this 2 here applied to the 10 milliliters squared. Now this can cancel out with this, and now you have 494 centimeters squared, which is the answer we want over here. See, determine the amount of material to the nearest squared centimeter. That's what you want. So that's how you do a conversion. If you're doing like conversion from area conversion, or it could be volume conversion. If it's volume, then you put a power of 3. But this is an area conversion, so you do a power of 2. The whole point, again, the whole point is to able to cancel these units out. So all you're left with is all you're left with is the centimeter units. Okay, that's done. Let's take a look at the next problem. And yeah, this is the last problem. Now, this is a bit of pain in the neck because like this, sometimes this won't be given to you, but I'm giving it to you right now. And yeah, so let's what you're gonna have to do, okay, let's read it first. A riser is a raised platform used on stage. The riser for a rock performance is to be painted. So you're gonna be painting it. So probably need to know the surface area. Determine the surface area to be painted. Do not include the bottom riser. Oh, okay, so you're not including the bottom half of it. Okay, do not include the bottom riser. So you have to imagine this flat, so flat out. So this is here is reimagine. So I drew it here, but if you're not given the shape, you're gonna have to draw it yourself. So you have to look at this and imagine it flat. And remember, there's no bottom part, so this is not bottom part. We're not even taking that into consideration. So we're gonna calculate the area of each face. So I have here this back here is this back here, and I'm gonna calculate the area of that first. So I'm going to say area of the back. That's going to be length times width, right? And in this case, let's say 6, 12, and that's going to equal 72. That's meters. Well, let me just go back there. I don't have enough space. Let's do it over here. 72 meters squared because it's area, and these are we're working in milliliters, by the way. Sorry, working in meters. And that's all, everything is in meters. So it makes things a little bit simpler for us. So we got the area of the back. Now, how about the area of the top? So this part here, I drew it over here, this part here. Same thing. Oops, this one's on top. Equals, again, length times width. Length in this case would be 10 width will be 12, or 12 times 10. It doesn't matter which order you go in. That gives you 120 meters squared again. Oh, this is going faster than I thought. Okay, so we have this side here, but this side here is not straightforward. You're gonna have to break it up in two shapes. So you're gonna have to go down over here and break it in that shape. So I know that uh, from here, well, from here to here is 16, and looking at the top, I can tell that this is 10. Therefore, let me do that. This last part, oops, this last part right here, that's going to be 6 meters, right? And you have that down over here. Okay, so the first thing to do, we're going to calculate these two, and then we're going to add them together. So let's do the area for S1. I believe it's S1, and that will be the easier part. So length times width, and that's going to be 6 times 10. That gives us 60 meters squared. That was easy, so that's done. Now let's do S2. Um, the formula for a triangle is base times height divided by 2, if you remember that formula. So S2 equals base times height divided by 2. The base here is going to be 6. Or they're both, the height and base are the same thing. This is 6 and that's 6. So you can say that 6 times 6 divided by 2. And I believe that should be 18 meters squared. And now we just can get the sum of that. So I'm going to say this is the side because I labeled it as side. So that will be these two numbers put together. I don't have enough space to, well, maybe do I have enough space? Okay, I'm going to write here oops, let's go back. AS1 plus AS2. And underneath here, we're going to write down 60 millimeters squared plus 18 meters squared, and that gives us 78 meters squared. Okay, so now we have the side. We have the side, and so we have this, and oh, remember that there's two sides. So we calculated one side, right? So we just we had to multiply that by 2 for 2. So this is just one side. This is the area just for one side. So keep that in mind. Okay, the last thing we need to calculate is this front. But the problem is we do not know what this x is. But I know that this part, this length here, is the same as this length here. So if you find the length here, then we know what x is here. The length here is here. So let's calculate that first. So basically, we're going to use Pythagoras theorem on this here. I don't know if you remember Pythagoras theorem. It's like c squared I think it's a squared plus b squared. So that's Pythagoras theorem, and you rearrange it so you have here will be x in this case equals root 6 squared plus 6 squared. That gives us 8.49, 8.49, and that will be in meters. So they use Pythagoras theorem to find that. So now this here equals 8.49. And I have that right down over here. So now we can find the area. Oops, let me just go back. We can find the area of this shape here. So I'm going to say area, and it's called front. Oops. It's again, it's length times width. Length here is 12. Width will be 8.49. And that will give us a value of 101, 101.82, and that's meters squared. Okay, so we have everything we need. Now we just have to find the sum of all the surfaces. And keep in mind that this side here, there's two sides. This side, so we're going to have to use that twice. So I'm gonna use times two. So area, or you're just going to call it, let's call it the sum. Because I would use the word sum right over here. So you use sum equals, and let's get all right. So we have what do we have here? The area of the back, the area of the top. So let's do area of the back and area of the top. So area of the back plus the area of the top. So that's the area of the back, area of the top, and the area of the side. And then because there's two of them, there's two sides. There's this top side and there's this bottom side. I'm going to multiply that by 2. So 2 times, and then it's the area of the side. I'm going to put this in brackets because it's just so you can know it's separated. And finally, the area of the front. Yep, the side, and the last one is the area of the front. So now we have the area of the front. So now we have we should have effectively this entire all the surface area of this entire thing. Now let's get our numbers, and our numbers are 72 milliliters squared plus well, let me just take a look here. 72 plus 120 milliliters squared, and then I'll put that in brackets. 2 times 78 milliliters squared plus 101.82 milliliters, meters squared, so not milliliters. Sorry, sorry about that. It's meters squared, and that gives us a final number of 449.82 meters squared. Okie dokie. So that is finding the surface area. Yes, it is a bit tedious because you have to like imagine it as a flat object and then find the surface area of the entire thing. And yeah, so all of this is just practice. Practice makes perfect. So do the homework and you'll be fine. Okay, that's about it.